right, geometry. My screen's flipping on me as we do this, but this is a big day. We're going to start our journey in proofs. We've been building up logical arguments, thinking about things logically, looking for clues to come up with patterns, and now we're going to kind of throw it all together with something that we know how to do. We know how to solve an equation, right? So sit back, relax, let's pay attention, and know that any argument, like if you're a lawyer trying to win a case, if you were talking to your parents about, hey, I want to get my driver's license, and they say, here are the things that you need to do and justifications why, or why you think you should get something from your parents, everything needs to have some sort of justification for it, right? If I went to my wife right now and said, hey, I want to get a skate sharpener, for my hockey skates, I better have some darn good reasons on why I need to spend that kind of money on a skate sharpener, okay? So what we're setting up here in the first part today is the justifications that you're going to use, the reasons that we're going to use on why we do things, okay? And then after that, we're going to practice. And what I did is I took 4-1 and 4-2 notes, merged them together. So you're going to have to do the same thing, but that's all right. So we're just going to start off with what a proof is. It's an argument, right? Some of you all like to argue, but we're going to use definitions. We're going to use postulates, previously proved theorems, so things like a squared plus b squared equals c squared. Definitions would be something like, complementary angles. If they give us complementary angles, we can add them together and equal them to 90 because that's the definition. The angle addition postulate, where you took the part and the part of the two smaller angles, added together to equal the whole thing. Stuff like that we're going to use when we get to the geometric proofs. Today, though, we're just going to focus in on algebra because we're good at algebra, and then we just have to justify each step. That's our goal. All right, so let's roll through these. And again, these are some of the properties that we will be using. So when you are going through and doing your proofs, having a small list of these, and I'll show you on one of the slides further down on what you might want to have available to you and what you can add to, so that way you have everything you need right there. All right, so when we're solving algebraic equations and we're add or we subtract numbers to both sides, multiply or divide, we are using these properties of equality. All right, so right in that middle it says properties of algebraic proofs. Okay, so the addition property, if we had to add a number to both sides, we would say our justification or reasoning would be the addition property. Right? Likewise, if we had to subtract 3 to both sides, oops, that's a y, we would call that the subtraction property. If we had to multiply a number to both sides, multiplying by 3 to both sides, call it the multiplication property of equality. And the division property, it's saying z equals 4, then x over 4 is equal to y over 4. We're dividing a number to both sides. So those are things that we're going to be really good at. And then we just say, oh, we added, so we're going to call it the addition property of equality, or multiplication, division, whatever. Okay? And then we had a couple other properties we used in algebra. Oh, we'll get to that one. These are going to be more properties of equality. May have heard some of these before, may not have. Reflexive. Think reflection. Okay? You are going to use the reflection property of equality when it's the same thing. All right? In geometry, where we would see that, if you see two triangles here, I hope you do, right? That side going right down the middle is a part of both of those triangles. So we would say, xy, let's call that xy. We would say xy is equal to xy because of the reflexive property. It's the same thing, right? So when we use the reflexive property is writing the same thing or being the same thing, okay? Then we have the symmetric property, right? Same on both sides, or think of flipping it around, it's the same. So all we're doing is if A equals B, then B equals A. May use this, right? Some of us like to use this property without even thinking about it, right? If 3 equals 2x minus 5, we like to have our x on the left side to start out with, so you can just rewrite that equation. Some of you do this, and that's all right. Your justification on that is the symmetric property, because it's 3 is equal to 2, or 2 is, 6 is equal to 2 plus 4, or 4 plus 2 is equal to 6. It doesn't matter how you look at that, okay? And we got the transitive property. I like to think of this. You got a $1 bill. What does a $1 bill equal? Well, a $1 bill equals 4 quarters. We're 25 cents a piece. Or a dollar bill is also equal to, we'll go, because I don't want to draw out 10 dimes. We'll call it 2 big 50-cent pieces. Okay? Well, what can I say about 4 quarters and the 2 50-cent pieces? Since both of them are equal to $1, I can say 4 quarters is equal to 2 50-cent pieces, right? Using the transitive property. So if you have one item, in this case it's B, equal to 2 different things, so B is equal to A and B is equal to C, using the transitive property, I can say then A and C are both equal to each other. I can cut out the middleman, so to speak, of saying they're both equal to one thing. Now I could say that they're both equal to each other because of the transitive property. So if x equals y and y equals 43, then that means x is also equal to 43. Or w equals x equals 5y minus 2, then that means w is also equal to 5y minus 2. And the substitution, if you have to plug something in, so to speak, if x equals y and I want to substitute in y, then it would be 4 times y plus 2. Or substituting in a value, x equals 5, then that's also equal to 3 times 5 minus 4. We're just substituting in. Okay. One more property here, and that's the distributive property. Right? If we have parentheses and you need to multiply it through, that is the distributive property. So if you're going to multiply a number through, our justification would be the distributive property. All right, go ahead, pause the video quick, and you try to figure out which each of these is saying, okay? So just try to match up each statement with one of the properties on the right. Take a minute, 2 minutes. As you can see, there's 9 things, 9 letters. Match them up the best you can. I'm going to keep going with it. You pause the video, try it out, and then we'll try some proofs here, okay? Well, number 1, what are we doing? It said D equals E, and then we were multiplying by 8, so we would call that the multiplication property of equality. We're multiplying both sides. Measure of angle 1 equals measure of angle 2. So 2 equals 1. All we did is flip around the order. That was the symmetric property. Symmetric property, so that would be F. All right, if AB equals CD, CD is also equal to EF. That means AB is equal to EF, cutting out the middleman. That is the transitive property. The transitive property. 4, 32 is equal to itself. That is the reflexive property. Think of reflection. It's the same thing. in the same order. S equals t, and then we're adding 3 to both sides, so that would be the addition property. Okay, can't divide by 0, so that's why it's saying C can't equal 0. That's the division property. Had parentheses. Parentheses are now gone because we multiplied a to both of those terms. That's the distributive property. Number 8, we started with x equals y, then it was 4x plus 5 equals 4y plus 5. Oh, shoot, which one is that? Is that subtraction or is that substitution? And we basically substituted in x for y. So that's substitution. That one's kind of weird to see in that case. And then the last one is subtraction. So there you have it. Now what we're going to do is we're going to do some algebra. And really what we have are, these are our properties. This is a nice list. This is something to screenshot, to add to, and then screenshot it, and saying these are the properties of equality that we're going to be using today to justify each of our steps. Okay? Combining like terms. You can say simplify because we're simplifying things, okay? So we're going to rock and roll. Well, that simplify didn't work out. There we go. What is going on? All right, so we are going to simplify. Subtract, multiply, add, all this other kind of good stuff, right? So what I did is I took the 2 notes and merged them together on one. So it's 9 for day 1 and 9 for day 2. They'll both be in the folder. You just can merge them together or have it 2 separate ones. And then we're going to practice some of these, and then I want you to practice them on your own and then look up in the notes section in the resource folder and have you check to see how you did, okay? So the very, very first thing we're going to do is whatever they give us here, we are going to write right here in the very first 2 spots. Okay, so we're going to put 4 times x plus y equals 48. And I'm going to spread this out. We might run out of room at the bottom. I don't care. We're going to put whatever's given in the very first one, and the reasons we're going to use are given and given. So anything we write in this statements column needs to have a justification to it. So if I write something in this spot here, then I better have a reason for it. If you're going to say something, better have a reason for it. Okay? But really, realistically, what we're going to do is we're going to go through and do algebra and then just justify everything. So with some of these, it might not be that bad for you to go through and do the algebra. What did I just do? I just substituted in the value for y. So the substitution property of equality. So you can write out property of equality, or you can put POE. If it's not there, you're going to be losing some points, okay? So all we did was substitute now, and then we could say, all right, let's go through and solve. All right, some of us will go, hey, I'm going to go like this, multiply that through. What was that? What did we just do? What do we call that? That was the distributive property. And we would say, hey, we're going to subtract 24, both sides. 48 minus 24 is, ooh, you're right, 24. That was the subtraction property. And then we would divide by 4 We get x is equal to 6, and that was the division property. Weird. How do you know when you're done? When you get that in the last box, right? That should be the last thing in there. What you prove is the very last thing. So this was our order in which we did things. Now there's a couple different ways you could have done this problem, right? And then our reasons would be different. But the idea is we're going to solve the algebra, and then we're going to write the properties over in the reasons. So every time we do something, you have to have a meaning for it. You got to let me know what the meaning is, all right? And that's going to go in the reasons. Okay, let's try one more. And then I'll get you, then you can try 2 on your own, and then we'll go over them and call it a day. Okay? So 5x minus 3 equals 52. Why do we put that there? That was given. All right, well, how are we going to get to x equals 11? We're going to run out of space here a little bit, but that's all right. So we're going to add 3 to both sides and get 5x equals 55. What did we just do? We did the addition property of equality. And then divide by 5, x equals 11. God, that's awesome. I love it when a plan comes together. And then that's going to be the division property. That's what we did, is we divided both sides by 5. So we call that the division property of equality. I don't know why my iPad's not picking stuff up. And we move on, go to the next one. Okay? Ooh, all right. You guys try this one. And you guys pause the video and try this one on your own. And then we'll come up with some reasons. And then we have lots of practice. So if you're like, I don't get any of these, oh my gosh, I want you to try these out on your own. Think of, hey, we got parentheses, we're going to be multiplying using distributive property, all that kind of good stuff. Okay? I'll probably jump down and do one of those at the end as well. So let's try these 2 on our own. So pause the video, try the next 2 on your own. See how you do. Now, here's the thing. I might do it one way. You might see it to do it a different way, and it's the same thing. So if yours is different, please ask me, and we'll take a look and see if your logical argument is making sense. Okay? So go ahead, pause the video. All right, well, first off, I'm going to put in that. Now we got to solve for x, so I'm going to add 3. Get x over 3 is equal to negative 10. That was the addition property. And then how do I get rid of dividing? I'm going to multiply both sides by 3. Get x is equal to negative 30. We call that the multiplication property of equality. All right, and then just double check what you're trying to prove should be the last thing in the statements column. All right, this one has got some cool steps to it, some different ones. So we're going to distribute, well, what am I doing? Yeah, right. Now, what you could do is solve this problem on the side and then write your steps in too. All right, so that's given. We're going to multiply that 2 through, so that's going to be 8 minus 2x minus 5x equals 78. We call that the distributive property. All right, now what would we do algebraically? Well, we got these 2 guys here. We're going to put those together. What did you just do? we combine like terms. And then we subtract the 8. Negative 7x equals 70. Go POE. And then last but not least, the division property of equality. So anytime you write something, needs to have a justification. Let's just triple check. X equals negative 10, x equals negative 10. Life is all good. We're doing good things. And then I'll go through this guy here. It's a lot to write to begin with. And you can do multiple steps at once if it's the same thing, right? It's a lot of stuff going on there. So lots of parentheses. So if I said this was 8x minus 32 is equal to multiplying 1/7 in there, that's dividing by 7. So that's going to be 7x plus 10 plus 2. I just did the distributive property twice. So if you're doing the same step at the same time, but it's on both sides of the equation, you can write it all as once, okay? Now what would you do? Well, I would collect my like terms. 2 plus 10 is 12. Now, you can also use this word too, because all you did was simplify. That's what you're doing when you combine like terms, you're simplifying things. And then I'd subtract 7x. And get x minus 32 is equal to 12. And then last but not least, we're going to add a 32 to both sides. And get x is equal to 44, and that was the addition property. And just double check. X equals 44, x equals 44, we're good, okay? So just take deep breaths when you work through. Every time you go move down the statements, got to fill in the reasons, got to have a justification for everything. Again, you might want to take a screenshot of this last page right here, and we're going to be adding things to it when we talk about the geometric proofs, right? What are we going to use for definitions, or what are we going to use to say we can do things? So you could add to this list if you want, make a separate list, do what you need. But why don't you try the rest of these out, check your notes in the resources folder.